Okay, so for section 5.2, question number 29, it's x squared times e to the x minus 3. So we're going to be using a product rule for this, which basically means we're going to take all this for the x squared times e to the x minus 3, and then just the derivative ex, and then the whole thing. Let me show you. So basically what you're going to do is you're going to take the derivative of this right here, the whole thing. So it's going to be 2x e to the x, that's it. That's all you got. Then we're going to have plus x squared e to the x. Now why is that? We're taking a product rule. So basically that means whatever this is multiplied by, we need to take the derivative of this first and then take the derivative of the regular equation. So since that x squared is up front, we're going to have to take the derivative of that, and then we don't do that over here. We just take the derivative of the e to the x, which is just e to the x. Okay, so now that we know this, you can see that there's a GCF, which is an x e to the x, because we have an x squared here and an e to the x. So we can go ahead and factor that out. So it's going to be x e to the x times 2 plus x. Now that we are here, we're now able to find our critical points. So to find the critical points, all you got to do is x plus 2 equals 0 minus 2 minus 2. X equals negative 2. And then when you have an x e to the x, basically you can just make that 0 because 0 times e to the 0th power is just 0. So you know x equals 0. Okay, now that we have our two critical values, we can go ahead and make a graph. So we have 0 and negative 2 as our critical numbers. So we need a number on the left side of negative 2. So we can go ahead and say negative 3. We need a number on the right side of negative 2. So we can go ahead and put negative 1. And then now we need a number on the right side of 0, which can just be 1. So we can actually now go ahead and just plug these values in to find for the extrema. So all you got to do is get a calculator, and the formula we're going to be using is this right here, this one right over here. So we're going to find, I'm just going to show you the answer for it. We're going to find that the graph is going to be increasing from negative 3 to negative 2, and then we're going to find that it's actually going to be decreasing from negative 2 to 0, or negative 1, and then from 0 to 1 it's going to be increasing. So now that we know that we're increasing at the beginning, we know there's a max. And since we're going from a top to the bottom to increasing again, we know that this is going to be a minimum. So now that we have that, we can actually go ahead and then find our y value. So the extrema is basically relative mins and max, relative, I don't know how to spell relative, whatever, relate, max, and min, relative maxes and mins. So we can go ahead and plug these in to the original formula. So we can go ahead and substitute our x values, which is negative 2 and 0. So we can do 0 squared times e to the 0 power minus 3. Now remember order of operations. If you don't do order of operations, you will get this wrong. So we know that at 0, our y value is going to be 3. So that's a relative min. And we know that when it's going to be negative 2 squared times e to the negative 2 power minus 3. Remember, order of operations, or else you're going to get this wrong. You're actually going to get a really wonky number for right here. It's going to be 0.56 around there, minus 3, and it's going to be about 2.46 around. It's going to be somewhere around that. That's going to go ahead and be the answer. You could always put that in. It's also going to be negative, by the way, because you just subtracted 3. So it's going to be a weird, wonky number. Just go ahead and do it step by step in your calculator. I recommend having one of these. This is what I use, so I know I'm getting it right. So that's going to be your relative max. So at negative 2, you're going to have the y value be negative 2.46. And those are going to go ahead and be your answers. That's going to be your relative max. And that's how you do section 5.2, number 29.